Right, yesterday we did symmetry with respect to the what? The origin, okay? So what we're going to do today is we're going to do symmetry, but with respect to several other things that we're going to talk about, all right? So let me, first of all, grab this right there and put it there. So what I'm going to try to do is do my best just to freehand draw this thing. Again, like I said yesterday, you don't actually have to draw these graphs. They're going to be drawn for you. Eventually we will, though. Okay, we are going to eventually, the graphs that you're going to see right here are graphs that we're eventually going to draw. And I think it's pretty soon. It may possibly be this chapter, because I did flip through a lot of the lessons just yesterday, I think, just to see what was coming up. And I think it was this chapter. I flipped through a lot of pages. So anyway, you will be able to graph some of these things eventually. But right now, they just give you the graph, and you just have to talk about it and see what is it symmetric to, all right? With respect to, I should say. All right, so what if you had a graph, I don't know, like this? All right, went like that, and then it comes around. It's one full graph, and it comes around. Oops, let's try that one more time. Keep clicking that button. I don't know why they put those buttons on these pens. It's so dumb. Wonder if other people will complain about it. I don't know. All right, so here we go. So if you had a graph like this, remember we talked about being symmetric, having the mirror, all right? Where does it look like it's the same on this graph? Okay, it looks like the mirror would be on the x-axis, doesn't it? Would you agree? So if I put the mirror right here, it looks the same on the top as it does the bottom. Does that make sense? So if I wanted to fold it over, think of it that way. If I wanted to take half of that graph, fold it over so it matches up with the other part of the graph, the other half of the graph, where would it fold over? It would fold over the what? The x-axis. You with me on that? So we say that it's symmetric to the x-axis. Okay, so let's write that down, because we're going to do 4 of these. So this is the first one. Symmetric to the x-axis. Maybe I shouldn't apologize before I do something wrong, but I'm going to anyway. Just so that you know, it's been many, many years since I've taught this. It's probably been at least 25 years, okay? Since maybe at least 20 years since I've taught this stuff. So I'm going to do my best to explain it correctly, and I think I can do fine. But just so that you know, if I seem a little shaky on this, I probably am, because it's the first time I've really studied this in at least 20-some years, all right? So just bear with me on this. So we have an equation for this. I'm not asking you to graph it, but I will tell you what the equation is, all right? Just so that you kind of see it, you know what we're talking about. So if you were to graph this equation right here, it would look like this. Everybody see it? All right, so it's a little different. It's got an x equal. Usually we have y equals. Would you agree? All right, but this is x equals, and then you got a squared, and then you got a minus 4. Where do you think that minus 4 comes in? Where do you think that is? It's right here. It's where that, we call that the vertex, okay, where it comes out of right there. So so you can kind of see what's going on. So if I just had x equals y squared, what would it look like? It would look like this sideways parabola going this way, and it would hit right at the origin, right, if I didn't have the minus 4 there. What if I had plus 4 there? What would it look like? It would look like this, but what? Shifted over here. So it would be at plus 4, and it would go up like this and down like this. Does that make sense? Okay. Again, we're going to talk about that later. We're going to talk about what these shapes look like and how to move them around, how to move them up, move them down, how to flip them over, how to twist them, and all that kind of thing, all right? But they're just showing you what it looks like right now. What we want to do is just see, and the question is, what is it symmetric to? Is it symmetric to the x-axis? What do you think the next one's going to be? Symmetric to the y-axis. Very good, okay? And then it's symmetric to a couple other things you probably wouldn't guess, but we'll look at that in a second, all right? So before I show you the next thing, let me put a point here. What if I came over 2? All right, if I came over 2, then I'd go up this high, and then I would go down. Now, it should be the same distance. I just didn't draw that very accurately. But you get the idea, don't you? It would be the same up as it would be down if it's symmetric. Again, I just didn't draw it very well. Let's find out what that point actually is. We don't really have to do it, but let's put it in. So what if this x was what? What did I say was? 2. So if x was 2, what's y equal to? So if this is 2 equals y squared, what? This is minus 4. Let's get rid of the minus 4. Let's find out what our y value is. I'm solving for y. So what did I do? I put in a 2 for x. Do you see that? Just plugged in a 2 for x. What's y going to equal? Can you do it in your head? What do I do with that 4? How do I get it? Okay, I add it. Thank you. All right, nobody's saying anything. So I add the 4 equals y squared. So what's y equal to then? Come on. You should do this. What is it? Y squared equals 6. What's y?
3? No.
What is it? Say it. Square root of 6. Thank you, Audrey. Okay, it's the square root of 6. Because you square root this side, square root this side. I didn't think I was going to teach that today. But anyway, y is equal to the square root of 6. So where's this point? It's 2 what? Square root of 6, which is like 2 point something, whatever. Okay, you can put it in a calculator. I don't care. It's 2 point something or other. So what's this point down here then? This is really what I want to focus on. So this is also 2, correct? So I didn't change the x. What did I change? The y. So what is the y point right here without even putting it in here? Because remember, this is plus or what? Minus. Remember that from square roots? Yeah? You guys took Algebra 2, didn't you? All right. You should definitely know that stuff after taking Algebra 2. So it's plus or minus square root of 6. We did that in geometry, for goodness sakes. We talked about it in geometry when I taught it to you. All right, so what is this? 2 what? Negative square root of 6. Okay, it's not the square root of negative 6. It's negative square root of 6. Okay? So look, what's the same? Like even if I went like right here, right there, if I put a 0 in for x, then what's y? Y would actually be 2, wouldn't it? Anybody see that? Are you guys playing along or not? Or are you just sitting and letting me talk? I want you to think. I can tell if somebody's thinking if they're not thinking. Okay, it doesn't seem like we're thinking. What if I put a 0 in for x? What's y equal to? It's 2, plus or minus 2, right? Because move this over, right? If that's 0, you add a 4. Y squared equals 4. Take the square root. What's the square root of 4? It's 2, plus or minus 2, all right? So this is the plus 2, and this is the minus 2. So the 0 didn't change. What changed? The y changed, didn't it? You with me on that? Okay, so here's what I'm going to write down. Let's do this in a different color. What's that? How do I do what? Well, what is the square root of 6? It's 2 point something. How do I know it's 2 point something? Because the square root of 4 is what? 2. The square root of 9 is 3. So it's somewhere between what? 2 and 3. It's probably a little more than 2.5 because it's a little closer to 9 than it is, right? So let's put it in the calculator, see what it is. And yeah, it's 6 square root 2. Oh, it's actually not more than half. It's almost right at half, 2.449. So it's about 2.4. So you would just graph 2.4, okay, if you were to graph it. But again, I probably went off on a rabbit trail right there, okay? They just give you the graph and you have to tell what it's symmetric to. So this is 2 something positive and then what? 2 something negative. That's all you got to see, okay? I don't care if you know it's square root of 6. I really don't. Not right now anyway. Okay, does that make sense? So just know that if you go over 2 or 3 or 4, whatever, you go up a certain number and you go down to that same exact number. Would you agree? Same thing here. Watch. If I went over this far, then I go up and then I go down the same exact, right? Everywhere on here, anywhere on here, okay, wherever I pick that x, I go up and down. The x or the y is positive up here and the y is negative down here. So with all that said, I'm going to show you this. They use A and B for this. The A corresponds to the x and the B corresponds to the y, but they use A and B. Since they use that in the book, we're going to use that instead of x and y. Is that all right? So just remember the A corresponds to the what? The x, and the B corresponds to the y. All right, so this is how they write it. So they put A comma negative B, Now, this is weird, but I'm going to explain it a little bit. They say is an element of, do you remember doing anything like that? You put that little E? That just means is an element of, all right? Our set. S for set. That's good enough, okay? I'll show you in a second. At first it's going to be crazy, but then I'm going to put an arrow going this way and going this way because you can go both ways. It's kind of like equals, but it's really not an equals. It just means the left side and the right side would correspond to each other. All right, so watch. I'm going to put A, comma, B. After you see this a few times, it'll start making a little bit more sense to you, I promise. Is an element of set S, all right? Now, what I want to look at is this right here. That and that. That's the important part, okay? So, if it's symmetric to the x-axis, what we're looking at is a point here and a point right across from it. If the one point is positive, positive, and the other point is positive what? Negative, then it's what? Symmetric to the x-axis. Everybody see that? So sometimes they're going to give you, well, you'll see it in the next example. I tell you, we're just going to stick with this, even though it's going to look weird, even though you're not really sure what it means. Just hang on, all right? In the example, it'll make a little bit more sense, all right? So let me just keep going. So if it's symmetric to the x-axis, for every positive, positive, what's the mirror image of that point going to be? It's going to be what? Positive, negative. You see it? See, look. Or whatever you went. So even if I went this way, you're like, well, Mr. Hamrick, I'm going negative, all right? But if I go negative, then this goes positive and this goes negative, all right? Positive, negative. Those are our points. You see how they're mirror images of each other? Those points, these points right here, this point right here, and this point right here. One's positive and the second one is negative. Okay? So when the first one's positive and the second one is negative, that means it's symmetric to the x-axis. That means it folds over the x-axis. All right? So every time you see that, then you know it's symmetric to the x-axis. Let's do another one. Again, I understand. I can see the confusion on your faces. But after we finish these and then start an example, then I really believe you're going to look at it and say, okay, I think I'm seeing what you're talking about. All right? I really do. Hopefully you do. All right. So here's another type of graph. All right? It goes down like this, and it goes like this. Now, just looking at it, just looking at the graph, we should be able to look at it and tell what it's symmetric about, okay? So where does it fold over and you get the same thing on the other side? The y-axis this time, okay? So the y-axis. All right? So this graph is symmetric to the y-axis. All right? Because that's the place where if you fold it over, it's exactly the same. Everybody sees that part, right? That's pretty easy to see, I think. Do you? Let's pick a couple points. Let's say you had a point here and you had a point here. All right? So this, by the way, this is, here's the equation of this graph. It's y equals negative x squared plus 2. All right? That's the equation of this graph right here. So let's say you put in a point 2. We'll go 2 again. All right? What's this y going to be? So that point is 2 what? Let's put it into this. If I put a 2 in for the x, what do we get? 2 squared is 4. All right? It would be. Why did I put 8 right there? I don't know. Does anybody got their book? Because the whole thing is negative, right? Oh, it's plus 12. Okay, I was going to say, because I got an answer. I put a plus 2 in my notes, so that should be a plus 12. Thank you for that. All right, so I just misread what it said in the book. All right, so let's put it in there. Let's put a 2 in for this. So 2 squared is what? 4. This makes it -4. -4 plus 12 is 8. So what is that point? It's 2, 8. It's obviously not drawn to scale, but it's okay. All right. So what do you think this point is? So where do you think, how far over did you go here? You went 1, 2. How far on the x-axis did you go over? You went -2, right? You went -1, -2. So what's this going to be? Put it in -2. So -2 squared. What's -2 squared? +4. Then you apply this negative, which makes it -4 plus 12 equals what? 8. So what is this point right here? It's -2 what? 8. So do you remember what we did on this one? Actually, did we do it in yellow or red? Actually, it doesn't matter. I kind of messed up it. We did it in yellow. So watch this. So this is going to be -AB, correct? And this is going to be what? +AB. All right, so we're going to write it like this, with that weird notation that you probably don't completely understand, but that's okay. All right, it's really not that big of a deal knowing the notation. It just means it's a member of the set S. All right, just this thing is just considered set S. All right, and then it means, and then that goes with A, comma B. It's also a member of the set S. Now, what I'm looking at is this right here. That right there. If you see something, if you compare it to its mirror image, okay, if its mirror image is just AB, and the one that's directly across from it, like right here, you see that? That one that's directly across from it, if that's -AB, right, you went up the same Y value, but you just flipped completely on the other side. Instead of +2, it's what? It's -2. Anytime you have that, then what do? It's symmetric to the what? Y-axis. So this is symmetric to the Y-axis. I mean, it's easy to see the graph and know which one it folds over. But there are going to be some times where you're going to look at some points, right? And you have to know, is it symmetric to the X or the Y-axis? And that's a way to do it. You with me on that? So I didn't change the Y, I changed the what? The X. You see that? I changed the X from +2 to -2. The Y stayed the same. So the one that stays the same, that's the one that it folds over, correct? Look at the first one we did. What stayed the same? The X, right? 2 and 2. So if the X stayed the same, what does it fold over? It folds over the X-axis. Okay? Let's do another one. I know, it's weird. I can tell by the way you're looking at me. Like, Mr. Hamrick, this doesn't make any sense. All right, what about this one? Again, this is one that eventually you're going to graph. But you don't have to know how to graph it right now. They're just going to give it to you. All right, they just want you to see it visually, and then eventually you're going to see what it's symmetric to. Now look, they're completely separate of each other. So look at this one. This doesn't just flip left or down to get the other one, does it? How would it flip? Where would the mirror be on this one to get the same image? In the middle? What do you mean in the middle? Just at one point? Okay, so say it a little bit more specifically instead of just in the middle. I think I know what you're saying, and you are right. Okay, what you're thinking is absolutely right. But it's this right here. Is that what you're talking about? Okay. Technically, yes, it's in the middle. Okay, but what is that line right there? If you go over the same as you go up, what is it? It's y equals what? It's y equals x. That's right, because look, the y-intercept is 0. And look, if you go over the same amount as you go up, what's the slope? It's 1. All right, so it's y equals 1x plus 0. Agreed? or just what? Y equals x. So that dotted line is y equals x. That's what it's symmetric to. It's not symmetric to the x-axis. It's not symmetric to the y-axis. It's symmetric to that diagonal line, which is called what? Y equals x, okay? So this one right here is symmetric to the line, what? Y equals x, all right? Here's the actual equation of the graph. This right here is just the equation of the dotted line, okay? It's kind of like your x-axis or your y-axis in the other problem. But what is the actual equation of this crazy line and this crazy line? It's actually just one equation. And here it is. It's xy equals 6. It's really strange. But if you put that into a calculator, if you had a graphing calculator, or even just go on the computer, right, find a graphing calculator, you put that in there, that's what it'll look like. Let's just do that for fun, okay? So I go to Desmos. I don't know how you say it. Desmos. How do you say it? Desmos. Okay, good. If you go to that, what I say was xy equals, so watch, xy equals 6. Boom, there it is. And you see it? So that's it. That's your graph. Well, you can't see it online. I'll tell you what. I made this so you could see it. So let's do that. There it goes. Oops. Let's go back to this. There we go. Okay. So if you look at it, I believe this has a tracing thing. Yeah. So like if you go to 1, right? Come on. Almost. Right there. There it goes. Did you see it? I thought it. Come on. Oh, I can't let go of it without it moving. What was it? When it was at 1, it was at 1,6. Okay? There it is right there. You see it? 1,6. How do you know it's 1,6? Because if x is 1, what's y equal to? It's 6, right? Because 1, right? 1 times y equals 6. Would you agree with that? All right. What if what if x was negative 1? If it was negative 1, where is it? There it goes. It's going to be what? Right there. There it goes. Negative 1, negative 6. Do you see that? All right. So let's keep that in mind. So this was positive 1, positive 6, but the mirror image of it was what? Negative 1, negative 6. Do you see where we're going with this? All right. So let's go back to this, and let's write that AB stuff that we were writing earlier. So what do you think we're going to write? Actually, you know what? I didn't say that right. Let's try it again. Bear with me. Sorry. I'm new at this. Next year I'll be a lot better because I've already taught it and I'll know all the mistakes that I made. So let's see. Let's go to the 1,6 again. All right. Okay, let's do this. Here we go. I got it now. If I put a 1 in there, I'm going to get a 6, correct? What if I put a 6 in there? What if I put a 6 in for x? 6 times y, so 6y equals 6. What's y? It's 1. So if I go over here to 6, what should it give me? It should give me a 6, 1. Do you see that? So there's your mirror image. See this one and this one right there. See that? That's where if you put that diagonal line in there, and if you wanted to, watch this. Let's put one in there. So y equals x. There we go. All right, you see that? There's your axis, if you want to call it that. So this line over here, 6, 1. I can't really put a point there. Maybe I could. I just don't know how to use this properly. But if I put a 6, 1 there, Then I'm going to put a 1/6 there. Do you see how they're mirror images of each other? And they go across the y equals x axis. So that's really what I wanted to say. So now let's go back to this and let's write that down. So here's what we're going to do. If it's symmetric to the y-axis, then what did we do with the a and the b? We just switched the order, didn't we? So if it's symmetric to the y-axis, or to the y equals x axis, so b over a, what did we write? Is a subset of S. Okay. If and only if. That's what this means, if and only if. A, b is a subset of that set. Or is an element of. I think is an element of, not subset. Okay? See what we did? So anytime you have a point right there, where is its mirror image? Its mirror image is right there. So if this was AB, what's this point going to be right there? That's going to be what? BA. Exactly. With me on that? Okay. Same thing here. If I went over here, where is this point the mirror image of? This is negative whatever, negative whatever. What would it be here? It would be the same thing, except instead of negative 6, 1, it would be what? It would be negative 1, negative 6. You just switch the a and the b, or the x and the y, okay? So those would be mirror images of each other. Do you understand why it's BA compared to AB? Yeah, I think that works, doesn't it? Took me a while to get there, but we got there. I got one more, and then we'll be done. Let's copy that again. And let's do one more. This one looks... I think I might be able to use the computer to do this. We'll see if I can get it to slant just right. I'm going to make an ellipse, and I'm going to make like this. And then hopefully, if I go to this and make it 45 degrees, there we go. This should look like what I want it to. Yeah, look at that. That's pretty good. Make sure it matches up. Yeah, it's pretty good. Let's make it a different color, though. All right. So say we have that. Again, this is called an ellipse. We're going to be talking about it. We're going to talk about what the equation of an ellipse is, how to twist it, how to turn it, how to flip it, and all that kind of stuff. We're not going to do that just yet. But this particular one, at least in the book, here's the equation for it. Again, you don't have to worry about this, but I'm just throwing that in there just to show you what the equation is. There should be an equals in there somewhere. What did I miss? Who's got the book? Oh, I just didn't finish it up. Plus what? Plus 17y squared. Okay, keep going. Equals 225. All right. So that's pretty crazy. All right. That's the equation to this. All right. If you don't believe me, go to Desmos or Mos or Mus or whatever you call it and put it in there, and you'll see that that's what that looks like, something like that. All right. So where's the mirror image here? Is it y equals x? Well, I don't know. It might look like it is. It's not really that. Where it is this. It's this one. See how it'll take half that ellipse or oval, whatever you want to call it. We'll call it ellipse. Do you see that? Okay, if I fold it, this right here will be exactly right here. And if I fold this over here, it would be exactly. So this is the symmetry. This is the line of symmetry right here. So if the other one was y equals x, what do you think this line is right here? It's negative x. Y equals negative x. That's right. Okay? So this is one example. It's not the only example. It's just one example of a line or a graph that's symmetric to what? The line y equals negative x. Symmetric to the line y equals negative x. Okay? So we kind of do the same thing. Let's do that AB thing again. Probably won't get to the example today, but we'll get to the example on Monday. So watch. Let's say you had a point right here and this. See how that's directly across from it? Like that. All right. So if this is A, B, what do you think this point is? Yeah, that's my question. I wrote it down. Why did I put... Well, I'm a little stumped. Give me a second. Why did I put -1, -4? So what I did is I picked a point, okay, and let's say that that's 4, -1 right there, okay? What is this point? So I went over 4 and I went down 1. This point right here, where do you think I'm going?
Over 1, down 4.
Over 1, down 4, correct? But I still get it. I'd have to look. Let me see the book. I just want to see how they do it. Because I just did my notes, and I could have very easily not drawn something correctly. And that wouldn't be a first. All right, let me see this right here. Oh, they do put 1, -4. Why did I put a -1, -4? Yeah, that's right. I just wrote it down in my notes wrong. I put negative. So yeah, so if that was 4, -1, what do you think this point is? 1, -4. Okay, and look what I did. Remember, if this was AB, what did I do? What did I do with the A and the B? Well, first of all, I switched places, didn't I? This was the 4 first, then the 1 second, so I switched the places. But I also did what? This was +4, and I changed that to -4. This was -1, and I changed it to +1. So what do you think the A and the B thing is going to be now? What did I switch? So if this was AB, right? If this was AB, 4, -1, look what I made it into. I made it into 1, -4. So it's not B, though. It's -B, -A. Everybody, look. You can see it now. Watch. If the A was 4 and the B was -1, what is it down here? What is the A here? That's -1. What is the A here? It's +1. And what's the B? It's -4. So what did I do? I didn't just change the signs. I switched the A and the B around. Okay, I switched the order of the A and B, and then I did what? Change the signs. Exactly right. Do you see that? So instead of AB, what is it now? It's -B, -A. So we can write all this stuff right here. And then what's this going to be? This is just going to be AB, like this. All right. We will get to some examples where this will make a difference, okay, knowing this stuff right here. So if I switch the A and the B around and I change the signs of both of them, then we have a line, or then we have a graph that is symmetric to the line y equals -x. All right? So what do we care about? We care that this goes with symmetric to what? Y equals -x. Agreed? The BA, when you just switch the order, right, of the ordered pairs, then it's symmetric to a line y equals x. If all you do is keep the order the same, but you just change the first one to the opposite sign, then it's symmetric to the y-axis. And then, if you keep the order the same, but you only switch the b, right, the second one, the y value, if you just change the sign of it, I should say, then it's symmetric to the x-axis. So that's basically what you need to know from what we talked about today. If it's symmetric to the x-axis, then it's A, -B. If it's symmetric to the y-axis, then it's -A, B. If it's symmetric to the line y equals x, then you just switch the A and the B. So B goes first, then A goes second. And then if it's symmetric to the line y equals negative x, we switch them and change the signs of both of them. So that's how you know that if it's symmetric. So sometimes we don't know what the picture looks like. Like right here, you could just look at the picture and say, oh yeah, it's symmetric about, right? It folds over that line right there. But what if they don't do that? All right, what if they give you some ordered pairs and they say these match up? You have to know if it's symmetric to what. So those are the 4 things that you want to take away from today, all right? Is this is symmetric to y equals negative x. This BA is symmetric to y equals x. Negative AB is symmetric to the y-axis, and A negative B is symmetric to the x-axis. So you might just put them in your notes, put a little box or something, okay? And put A negative B, symmetric to the x-axis, okay? Negative AB, symmetric to the y, and then BA, symmetric to y equals x, and then negative B negative A, symmetric to y equals negative x. If you know those, that's going to help you do some examples that we're going to do a little bit later, okay? I know we haven't done anything concrete. I know we haven't really answered a question yet. We haven't really done an example yet, but what we're doing right here with that negative A, B, and all that kind of stuff, it will definitely help you be able to tell if it's symmetric to certain axes, okay? That's what we'll eventually do. So we're not there yet. I know it seems kind of empty, like what in the world did we just talk about? It will come to something where you're going to actually get some answers for some things, and you'll see if it's symmetric to this, symmetric to that, okay? I promise it'll get there, yes.
So do you not really need the second set of...
Yeah, it's all just, I hate to say it's fluff, but it kind of is. Okay, it's kind of like fluff, all right? But that's what math is. Math is a lot of that notation, right? And it is kind of weird stuff, okay? But what I said right here about this and this going together, that's really what you want to take from today, all right? Just make sure that BA goes with y equals x. Make sure negative AB goes with the symmetric to the y-axis, and A negative B goes with symmetric to the x-axis. That's really what we want to see right here, okay? Right, it's just negative B, negative A is symmetric to the line y equals negative x. So if you know that, you should be good to go. All right, I got 5 minutes. Let me show you that quick little video. I think it's only about 5 minutes long. I'm not going to record that, but I'll show it to you.